Hello, my name is Benson Hoagland with Opto 22. I'll be your host for our introduction to Groov RIO, I.O. for the IIoT. Thank you for dropping in. Now, this web conference will be a combination of presentation followed by a live demo. I'll present a few slides providing an overview, then I'll jump into demo mode and show off the Groov RIO's embedded software and its capabilities. I'll also demonstrate how Groov RIO integrates so elegantly with Inductive Automation's Ignition platform. So let's get started. But first, for those of you new to Opto 22, we are a California-based, privately held manufacturer of industrial automation hardware and developers of the software that runs on it. We have over 4 decades of experience with an installed base in the millions at thousands of customers all over the world and are known for highly reliable USA-made products backed by lifetime warranties. But what makes us unique in the industrial automation market is our engineering philosophy of combining OT systems and their traits of ruggedness and reliability with IT technologies like networking protocols, software tooling, and so on. And both of those into an affordable and capable system that can save you time, money, and effort and are suitable for a wide range of applications. And here is a drone shot of our factory and headquarters located in Temecula, California. We're about an hour north of San Diego, and this is where we design, build, and support everything we make. Now, before we jump into what Groov RIO is, let's first discuss the problem we're trying to solve. If you're involved in industrial Internet of Things, digital transformation, or perhaps Industry 4.0 type projects, you know that a huge gap exists between real-world data, meaning the sensors and systems that drive the industrial world, and the systems and software that need the data. And this real-world data, it's the fuel that drives these projects, and without it, projects can never cross the chasm from proof of concept to delivering value for the enterprise. Unfortunately, data for these kinds of projects, they typically come from PLCs, either new or existing, or maybe from some traditional remote I/O. And I get it. You know, Abraham Maslow, I think it said back in 1966, he says, "I suppose it's tempting if the only tool you have is a hammer to treat everything as if it were a nail." But frankly, that's an outdated approach for multiple reasons. And you see, traditional PLCs and remote I/O just really aren't right for the IIoT. Here's a few reasons why. First, just how difficult it is to specify and assemble all the necessary components to get the, the status of a pump or a motor, or read a temperature, or get a value from a transmitter. What's more is you're going to need, pretty specifically trained people just to help you out. Second, you're going to need costly and probably proprietary PLC programming software just to configure the I/O and then write PLC code to convert that data into something useful. And third, you'll need other systems, software, and engineering services to transform the data into something business systems can understand. Now, sure, you may already have PLCs and I/O installed, and those are in existing applications, but really, that approach hasn't been much easier either. The landscape is littered with projects that ended up in proof of concept purgatory. So I invite you to clear your mind. Forget what you know about traditional PLCs or remote I/O for a moment and consider what a new approach to obtaining operational data for your IIoT projects might look like. So, what features and capabilities might help us address these challenges if we took a fresh approach rather than trying to force existing technology to our will? Well, first, what if there was an I/O system that was extremely configurable and included everything required to get the signals you need with just a single module? Second, what if all that you needed was a web browser running on virtually any device to configure, commission, and troubleshoot this new I/O? And what if no programming was required? And finally, and arguably most importantly, what if this new I/O system could operate autonomously? What if it could connect to I/O and of many types and then exchange that data with software and business systems directly? That approach would dramatically simplify the task of getting operational data where it can be used for digital transformation projects and save time and money to boot. So I'm pleased to present Groov RIO, our new state-of-the-art Edge I/O module. It's what we've coined I/O for the IIoT, plus so much more. In a phrase, Groov RIO is an edge-based remote Ethernet I/O module designed for IIoT and automation applications. It's a fully featured standalone device with crazy configurability, rich with built-in features, and direct connections to your favorite software and cloud apps. So let's take a deeper dive. We'll start with configurability. There are 8 software configurable channels supporting a broad array of field signals, including temperatures, current and voltage, inputs and outputs, and discretes ins and outs. We've also added 2 electromechanical relays rated at 5 amps and up to 300 volts AC or DC. Now, when you calculate all of the possibilities, you end up with no less than 61,260 unique I/O combinations, all from a single I/O module. And for you math whizzes out there or doubters, we've even created a web page on our website that details exactly how we arrived at that number. When you see it, you'll believe it. Now, here's an illustration of how all the various I/O options map up to the RIO. First, there's our 26 terminal spring clamp removable connector with a single hold down screw. It's used the same termination on our Epic I/O modules. And the red dotted lines here, they indicate the multiple signal types that are wired up to each of the terminals. So at channel 0 here, you can see 3 terminal connections are reserved and how your input or output signals can be wired depending on the signal type. So for channels 0 through 3, 3 terminations each supporting voltage or current, analog inputs, ICTD temperature sensors, thermocouple or millivolt inputs, discrete inputs, or DC syncing outputs. Now, down here we have also 4 channels 4 through 7 have 2 terminations reserved for each channel, supporting voltage inputs, ICTDs, discrete inputs, current or voltage outputs, and of course, DC syncing outputs again. Finally, channels 8 and 9 can be wired normally open or normally closed Form C relays. So, pretty crazy, right? And when you do the math, well, you know. So now that we're set for signal types, let's discuss power options. We have 2. Standard line power with a wide 10 to 32 volt DC range, and something we're really excited about, power over Ethernet. So now, with a single cable, we can provide both power and communications to the RIO. What's more is we'll also power the I/O from either of these options, including loop power for your 4 to 20 milliamp loops, voltage, and even wetting voltage for dry contacts wired up to any of the first 8 channels. Now, talk about reducing installation time and costs. Imagine a simple dry contact, say on a pump or a motor, combined with the PoE-powered RIO, and you're already on your way to capturing data you can integrate directly with, say, your predictive analytics software. And that's just one simple example. And let's, now that we're talking about integration, there are loads of options here. Now, one we're really excited about is our extremely simple and elegant integration with the Ignition platform by Inductive Automation and the Canary Labs Historian, both of which support MQTT and Sparkplug-B, which I'll talk about more in a moment. There's also built-in tools for communicating directly to cloud systems like AWS, IBM, Microsoft Azure, just to name a few. Or maybe, cloud's not your thing, and you just want to move OT signal data directly to a database, whether it's SQL or otherwise. Or maybe you're really out there and you want your I/O data showing up in your favorite Slack channel, or maybe even text or tweet it to the masses. And no worries, RIO can do that too. So here's a simple system architecture that illustrates kind of the path of the data. So at the bottom, we've got our various I/O signals and devices connected up to the RIO, and then software embedded on the RIO can securely push that data up to on-premise applications like databases, MQTT servers, or an Ignition gateway, or perhaps to the cloud platforms I mentioned earlier. And I'll also show you how you can get this data right onto your devices, either through the SCADA software or directly to your device's web browser. Stay tuned for that in the live demo. Okay, maybe all that cool software and business system connectivity isn't really your bag yet, and you just want to hang Groov RIO off of an Ethernet network as remote I/O. Got it. Well, we support Groov RIO as remote I/O in a number of ways. First, our real-time control engines on our Groov Epic platform fully support RIO and all of its thousands of I/O configurations natively. Just add RIO as I/O in your control strategy and off you go. Maybe you're not using our state-of-the-art Epic system, but perhaps our older generation Snap Pack systems. Well, even those decades-old systems support RIO as remote I/O. How's that for backward compatibility? But maybe your PLC or other industrial device, or maybe it's software, supports Modbus TCP. Well, Groov RIO is a full-on Modbus TCP slave, and all the I/O and all the other data are fully exposed via Modbus registers. So you're set there too. And for you devs in the house, RIO is a full-on HTTPS web server with a very rich RESTful API all built in. Or if you prefer a higher level language, we have free SDKs at developer.opto22.com that works, all of them work with RIO. So knock your programming socks off. And here's a modified version of that system architecture I showed a moment ago with our PLCs, Epic, and other devices communicating up to RIO as remote I/O. Pretty straightforward. But again, while RIO can be a slave to some other master system, it can also perform all the functions I previously described simultaneously. So maybe we provide data to your PLC or software application, while at the same time publishing data directly to Ignition SCADA, the Canary Historian, maybe a cloud service, all at the same time. You starting to see RIO's versatility? So let's cover the MQTT publish subscribe capability that I briefly mentioned earlier. RIO has a built-in support for configuring and publishing your I/O data directly to any MQTT broker with two choices in payload. Our favorite is the open source payload and topic namespace definition called SparkPlug-B, which is also natively supported by Ignition and Canary Labs. But we also support simple string payloads for those just, dabbling in MQTT and smaller non-critical applications. No worries, your choice. But rather than just publish process data and discrete states, we can also publish metadata about the I/O as well, including counts, min-max values, and more. You'll see all this firsthand in the live demo. What's more is MQTT is bidirectional, meaning RIO can also subscribe to changes that other systems publish and then write those changes to output, making this pub/sub model capable of control as well. Yep, I got a demo for that too. So here's a system diagram of how MQTT works in a pub/sub model. My RIOs down here are publishing their data securely up to an MQTT broker, and the top level subscribers can subscribe to the data they care about completely decoupled from the RIO devices. All of this happens securely because RIOs support TLS encrypted connections to the broker. Now, a few words on the broker. MQTT brokers or servers are just software running on some compute platform. And these brokers can scale from something as simple as the free open source Mosquito broker running on a Raspberry Pi, all the way up to mission critical, highly available server farms running industrial grade brokers like the Chariot broker from MQTT inventors Cirrus Link Solutions. Now, one option is to install and run the MQTT distributor module right on your Ignition gateway. That'll get you up and running quickly and easily. So lots of options for sure. Now, maybe your real world data needs are a little simpler and you just like to log data locally and work with it later. No problem. RIO has a number of options for locally storing data. First, there's over 2 gigabytes of local drive space on power fail-safe eMMC memory. Now that means you won't have to worry about file corruption due to an inadvertent power loss. That's a really nice safeguard that most eMMC-based IIoT devices on the market today simply don't have. And if you need more space, simply plug in a USB mass storage device in the USB port right here and log your data there. And the USB port can alternatively be used for USB to serial adapters or a supported USB Wi-Fi dongle. Now, no IIoT product discussion is complete without addressing security. And indeed, we've been building our Groov line of products since 2013 with built-in security from the ground up. And everything you need and expect is there, from encryption to user accounts, firewall, certificate management, even open VPN client. Now, we know a thing or two about security in OT environments, and let me tell you, we've got your back here for sure. Now, on to installation. Groov RIO is built to industrial standards and designed for long-lasting, reliable operation in almost any environment. Included are 2 mounting options, both DIN rail mounting and panel mount. Now, your choice, and they're both built in. There's no extra parts that are required. And with a wide operating temperature range, plus Class 1 Div 2 hazardous locations approval and ATEX compliance, you can place RIO just about anywhere. Okay, so how do we get the real world IO data where it needs to go? Well, for that, we'll use the powerful open source IBM developed software named Node-RED. And like I said, this is open source and freely available. Now, Node-RED is a really intriguing and visual way to create connections between your IO data and just about any software or web service out there. It's ideal for moving data, for storing data, for performing simple logic, and a whole lot more. I should note, Node-RED is not designed for real-time applications and not meant to replace a PLC for high-speed closed-loop control. However, it's certainly suitable for a number of tasks that all get executed right at the Groov RIO level. Now, I'll be demonstrating some of the power of Node-RED in my live demo coming right up. And now, the moment you've all probably been waiting for. What does a powerful, versatile, exceptionally configurable IO module like this cost? Well, we're pleased to offer Groov RIO for just $749 US list. This, of course, includes all the embedded software tools, all the protocols, device management, and you'll never have to worry about recurring costs like maintenance or updates. Everything is included. Now, we do provide a couple of accessory items to complement your RIO, primarily to further simplify, your installation time and, of course, costs. First, there's our IP69 rated polycarbonate enclosure, which we've outfitted here at the factory with a backplane and some DIN rails in there and the cable glands you see there at the bottom. And then second, we also offer our pre-wired terminal block with 6 feet of 26 wires to flying leads, jacketed in a flexible sheath with a heat shrink neckband. Now, this wiring harness can certainly significantly reduce the labor in wiring RIO, maybe to a terminal strip should one be required. Now, one of the questions we frequently get is, how does our new Groov RIO compare to Opto 22's flagship Groov Epic? Well, as you can see, both Epic and RIO offer industrial grade IO with built-in support for standard open source technologies like MQTT, Sparkplug-B, and Node-RED logic. Both also offer a fully configurable firewall and an open VPN client for allowing remote access, configuration, maintenance, and so on. And you can do that from just about anywhere on any network. Now remember, EPIC is an acronym for Edge Programmable Industrial Controller, and as such, adds capabilities for real-time industrial control, edge processing, full mobile and web-ready HMI, plus a whole bunch of gateway functions. EPIC also runs Inductive Automation's Ignition software, both their full and edge editions, and that's ideal for connecting to and securing PLCs from such brands as Rockwell Automation, Allen Bradley, Siemens, and more. Now, EPIC also benefits from a built-in touchscreen plus an HDMI port for adding an external industrial touchscreen display. And finally, EPIC offers 2 segmented gigabit Ethernet interfaces for segmenting OT devices from the IT network, whereas RIO's actually has a switched interface, and that allows you to daisy chain RIOs. Okay, sweet. We reached the point in this webinar to switch gears from slides to the live demo. From here forward, I'll take you on a deep dive into Groov RIO's configurability and integration with other software applications. All right, let's get started. So first things first, let's take a look at my demo unit. There it is, sitting here on my desk. So let's zoom in and take a closer look here. Indeed, I've got my groov RIO mounted right here on my DIN rail. You can see I've got a label with all those certifications, my default host name. Got some nice LEDs right here to give me an indication of what's occurring on the device. We'll talk more about that in a moment. You can see there I've got a little USB plugged into my USB port, and I've got a load panel here. So you can see that I've got a couple of push buttons and some ring LED outputs. I've got a little potentiometer here, which will indicate my tank level. I've also got a little temperature sensor there. It's an ICTD temperature probe, so we'll be messing around with that as well. But the really cool thing here that I want to show you is this. There's only one cable that's connected to this guy, and that of course is my Ethernet cable, and that is power over Ethernet. So I'm doing communications and power for the entire system all over one Cat5 cable, and that's running along the floor there up and around to the back demo table there where I've got a PoE switch. Then that PoE switch is connected to my corporate network. So by virtue of simply plugging this device in into a PoE switch and getting my communications and power, it's also an intelligent device designed to work on IT networks. And by that I mean it supports standard IT tools such as DHCP and DNS. So as soon as this guy gets on the network, he'll obtain an IP address, register its default host name with DNS services, and that's going to give me the opportunity to go in and configure the device. So what I want to do now is go ahead and let's drop this screen down. I'm going to keep the screen up though throughout the live presentation so you can kind of get a sense of how things are working as we go through it. So here I am in my web browser, and as I said, we're on the network. My default host name was registered, but I have since, of course, configured the device and changed the host name to something a little easier for me to remember, and that is my first name. So there you go. In the URL bar, I simply type in RIO-Benson, and look at that. Okay, I've got a login screen to log into the RIO, and of course, that's the web server that's built right into the device, and I'm indeed connecting to that web service or web server over HTTPS. So just the same type of security you would have logging into your bank or into google.com. So naturally I can log right in here and get to configuring this device. But I told you before, you really don't even need a PC for that either. Because it is a web server and because it is set up for responsive display, that means I can use my phone here. So I want to show you. I'm going to go ahead and share my phone screen with you. Got a nice little screen mirroring application here. And there it is up on screen now. So we'll go ahead and scroll back, and there indeed is my home page. And you'll see right there, there's a Safari browser. So I'm going to choose that one. I'll click on it. And I do have a shortcut to RIO Benson. So I'm going to click on that and save me the typing. And look at that. Okay, so from my handheld device, I'm actually able to log on to the device as well. And if you think about that, that means I might be trying to deploy this. It's in a cabinet, or maybe it's in some far-flung location. And as long as the RIO and my phone are on the same network, I can access it from there. So let's go ahead and log in, and I'll go with that password, use Face ID, log right in, and voila, there I am. So same as you can see on the screen there. Let's go ahead and I'm going to click on the system button. So that's indicated here. So click and come up here to network. And as I indicated earlier, my host name is RIO Benson. That's what I gave it. And that's easy enough to configure. I'll show you in a moment. And you can also see that I'm indeed on Ethernet 0 connected to the Opto 22 network, where I obtained this IP address, and I've also obtained a gateway to the internet. And this is standard. Same as if you put your PC on the network, you'll get an IP address, and then you'll get some other settings which allows your PC to connect to the internet. And for you keen eyes out there, you'll probably notice I even have my Open VPN tunnel automatically connected, and I've configured it that way. And notice that it has its own IP address space. Now, why might this be important? Well, think about this. Maybe I have this deployed and it's maybe in this building, but then maybe I want to access it from outside of the building. Sure, I could dial into the Opto 22 VPN, but this allows me to actually access from anywhere. This is dialed into an open VPN server that's up on Amazon Web Services. And that means from anywhere in the world, I can, with this device or any device, log into that same VPN server and get a direct connection to my RIO. This would allow me to remotely configure it, remotely maintain it, view any of the node red flows, all kinds of stuff. So more on that on another video. We'll keep this one simple. Now I could go ahead and present the entire groov RIO interface from my phone, but frankly that is going to be probably a little tiresome for you and easier if I just do it right from the browser. So I'm going to go ahead and put my phone down and log in through the browser here. Okay, so I'm going to click Opto. That's my username and password. Note that I still have to log in here, even though I'd already done it on my phone. This is a different client. So I log in and boom, there we go. We're on the home page. So same thing, same kind of interface here. You see the same buttons that I saw through my phone interface. All right, let's take a tour. We'll start with security because that's always so important. First things first. Server certs. So if you're wanting to talk to this device securely, you need to create a server SSL certificate. No problem. We have all the tools in there to make that really easy to do. Same thing for client certificates. If you need to upload a client certificate to talk to another server securely, we have the method for doing that. And finally, our firewall. As I indicated earlier, this device does have its own firewall, and it will permit traffic on 443, which is the HTTPS secure port. But note, when we ship it from the factory, it also includes open ports for Opto MMP and Modbus TCP. And those are primarily there so a RIO can serve as a remote IO device, and some other master can communicate with the RIO and pull back its IO tags. If you're not using this as remote IO and you're using it more as IO for the IIoT, you can close these ports and have a 100% secure device on the plant floor or wherever RIO may be deployed. Okay, let's step back. We're going to take a look under the info and help button. A couple quick things here. There's a lot here. I want to point out two things. First is the documentation. All the documentation for your groov RIO is embedded on the device. So I can simply click on this, loads in a new tab, pulls the PDF directly from the RIO, and there's all of my user guide and all data sheet documentation all included, ready to go. So that's pretty slick. And also for developers in the house, we've got all of our REST APIs that are built into here as well, including the Swagger document. Again, all built in, no need to go anywhere else for that kind of information. Okay, maintenance, as you would expect, we have tools here to both back up the device and to restore it. Both of those can be done selectively. I can choose to just back up certain things or back up everything. Same with the restore. And then as new firmware comes out, very straightforward to update the device. You simply log into this page, download our firmware from our website, and simply update the system here. So that's pretty nice and real simple to do. Okay, let's take a trip back into the system button, the same navigation I was doing on my phone. And let's take again a look at the network. And the reason is you can see the same as what I saw on my phone, my corporate network connection here, my VPN connection here. But let's say you need to deploy RIO on a private network that doesn't offer DHCP services and is on a non-routable address space, and therefore need to provide it with a static IP address. No problem. Click over here on configure, and there you can see my IP of v4 method can be static. So I can come in here, fill in the blanks, and turn it into a static IP. And generally, you might want to do that for remote IO, as you know, a lot of PLCs and stuff don't know how to deal with dynamic addresses. And they need static IPs. Same thing with my OpenVPN. It's all set up here. If I had Wi-Fi plugged in, I may configure it from right here. Okay, we're going to take a step back and look at the time. Indeed, Groove RIO can keep its own time and keep it updated. So this is kind of cool. We've got an NTP client in here, network time protocol. I can set my time zone wherever that might be, wherever the device is deployed. That will update its system clock and then keep it accurate by pointing to an NTP time server. Those time servers can be on the internet, or they could be a local time server on your local LAN if you didn't want to provide access to the internet. Okay, let's talk about USB. I mentioned a couple of things, that the support for USB for data logging, not only for the USB, but also local storage. Let's start with the USB. And when I go in here to click, you'll see that it says enable USB. And this is important to know. When the device ships from the factory, USB is not enabled. Okay, so you must come in here and enable USB functionality. And then while you're at it, you may want to go ahead and create auto mount or permit it to mount that as a local drive to the file system. So both of those are selected there, no problem. We'll jump in here into files, and there you are. You've got your internal drive and you've got your USB drive. And I can go and browse each of those drives right from the interface here. So I'm going to click here on my USB stick, and this is my personal USB drive. As you can see, I've got it plugged in right there at the bottom. And I've got a couple of different files on here. Well, let's take a look at this one. It says RIO Benson P&ID SVG. Well, SVG is just a graphic format, so I can see, how much space it's taking up, when it was last modified. But let's go ahead and open it directly from here. And look at this. I actually have a graphical image of how my device, this particular device, is wired up. And this was really easy to create. We have a nice tool on our website. It's called the RIO Explorer, and I'll show you more information on that in a moment. But the RIO Explorer allows me to select certain I/O, basically configure the system with all its different channel configurations, and then save that as an image. Indeed, that's what I've done here, and I put it on my USB stick. So I'm going to close that tab, come back to here, and then you know what? I think I want my documentation actually on the device, not on the USB. No problem. I can just copy it there using these tools here. So I can say the destination will be my internal drive. I can see my directory listing, it's not there. So I'll select it, and the file was copied. Let's go over and take a look at the local drive storage and see where we are. There we go, secured files, internal storage, and there's my P&ID drawing now loaded onto local storage. I also have another file here called, it's a logo RIO. Let's take a quick look. Oh, it's just a Groove RIO logo. I'll show you where I'm using that a little later in the demo. And then let's go back and check this out. I've got temperature log CSV, comma separated value file, pretty straightforward. What I'm doing is I'm logging temperature from my little temperature sensor here every 15 minutes to local storage. I'm using Node-RED to do that, and I'm going to show you that flow coming up in a moment. But first, let's take a look at this file. So again, I'm on the local storage of the Groove RIO. I click open. It's going to open up my default editor for my CSV files, which in this case is Visual Studio. There's my epoch time, and there's my values, all at 15-minute intervals. This file is local to the RIO. Now I can download that file to my PC, I can copy it, I can move it, and let's think about that for a moment. Let's say that I am taking some value from IO data, like the temperature, and I'm logging it every 15 minutes. And then at the end of the day, say midnight, I want to take that file for that day and copy it over to USB or to anywhere. I can do so by using these commands. All the commands I'm using here are accessible from the web API. So that means I can write a very simple flow that copies these files or moves them wherever I need to be at any given time. So pretty slick there. Okay, so I'm going to go back up to this hamburger icon and go to the home page. And one thing I do want to mention, you notice that I logged in with my username and password. And that's something I'd created, because the Groove RIO does not have a default username and password. In fact, in my opinion, no IIoT device that's going on a plant floor network or anything should ever have unfettered access to the device or a default username and password. So indeed, when you first put this on the network and it gets its IP address and you attempt to log in for the first time, you must create an account. Those accounts end up here. The first account you create is a system-wide administrator, but you can create other accounts with limited access. In this case, I've created an account under my own name and said it only has Node-RED editor or REST API access. So that means you can limit access to this device by creating other user accounts. Okay, pretty slick. We've covered a lot relative to getting the device set up and a little tour there. It is an I/O system, so let's jump into the I/O. We'll start with the I/O reference. And here you'll see that I've got my Groov Epic modules. Remember my Epic here. And this is just for your own reference. So if you are connecting as well to Epic I/O, there's a lot of information there. But we care about this one right here. This is the mixed signal multifunction Groov RIO, the one that I'm communicating with right now. And this is the part number for that particular device. And I mention this because this Groov RIO is the first in a family of a number of Groov RIO products we will have. And indeed, each of those will be listed on the RIOs when they become available. So in this case, we are talking about this particular device. So I'll drill into that one by clicking and note this. All of my specifications for all the available channels that can be configured on this device are at your fingertips. I've got my ranges, I've got my accuracy, I've got my speeds. So there's a discrete counter input that'll count to 10K. I mean, it's all here, right at your fingertips. Look at this, I've even got 8 different thermocouples that can be wired up. By the way, those 8 thermocouples were not part of the calculation of the 61,000 unique configurations. When we put the 8 thermocouples in, the number was so astronomically large, it became almost unbelievable. So let's take a look at the current input here. I can see the range, I can see its over range, its resolution, accuracy, everything's there. Everything's ready right there at your fingertips. But let's say that you're getting ready to wire up your transmitter and you want to know how to wire it. Good news, we've actually put the wiring diagrams right on the RIO. So there you have it. Each of the channels that are supported for a 4 to 20 milliamp input, or 0 to 20 is its full range, and how to wire it. So again, everything you need right at your fingertips. Okay, I'm going to go back to the home page once again. I'm going to go into IO config. Now this is kind of an overall IO configuration for the entire device. For years for decades actually, we've been doing temperature conversion automatically down at the IO level. In this case, if you have a thermocouple or ICTD, will automatically do the temperature conversion for you and return your engineering units in Celsius or Fahrenheit. We also have some Modbus settings here, whether the Modbus TCP slave is enabled or not. And also, if you have to change the float format, we have a method to do that as well. Now, while I'm on the subject of Modbus, I mentioned earlier that we have some tools that are built in for calculating the Modbus registers. So yeah, indeed, I can take any MMP address, which is any of the data areas on the RIO, and I can quickly and easily identify the unit ID and register address without having to resort to some manual and table full of information and trying to do cross-referencing. It's all built in. That's going to make your job much easier if you do want to have RIO as a Modbus slave. Okay, let's jump into the real deal. This is the IO itself. Okay, so in this case, we're looking. We can see that the top button is latched on. We also have the blue ring LED that's on there, and so on. So at a glance, I can see various IO states for the entire 10 channels of the Groov RIO. But let's take a little bit deeper dive. So I'm going to go here into channel 1. This is a zero-based device, so channels 0 through 9. Channel 1 is configured as a DI. Let's take a look. Digital input. It's got its name, the module type, which doesn't change, the channel type, 5 to 30 volts DC, and then the state. So I can come in here and I can confirm that, well, if I press the right button, there we go. The state is on or off. So essentially what I'm doing is checking my wiring, making sure that everything is wired up properly. If it wasn't, I may flip on over to the IO reference and confirm that I have it wired up properly. But indeed I do, which is terrific. But how did this particular channel get configured? Well, that's what the configure button here is for. So we'll click on that. And here you can see I can give it a name, whatever I like. The module type, as I said, doesn't change. And then here's the channel type. This is where I actually give channel 1 its so-called personality, how I configure it in one of those 61,000 ways. How do I do it? Simply click and look at this. I have a menu of all the options that are available to me for channel 1. I got my digital outputs, analog inputs, current inputs, all the thermocouples, millivolt input, all selectable. You simply select the one you want it to be, and it will be configured in that manner. What's more is in the case of digital inputs, I mentioned this briefly earlier, channels 0 and 1 have special features, high-speed features that are available. For example, this one is currently configured with the feature of counter. But look at this. I can do on pulse, off pulse, frequency at 10K, period measurements, totalizer. I mean, think of it this way. I could have a dry contact, say on a motor or a pump, and I want to know the runtime of that and keep it totalized right at the RIO device. I can do that right here. Channels in 0.1 support those advanced features. And then once I select the feature, it now has that personality. But it has more than that, of course. It's a counter, but I can still read its state, whether it's on or off. And that's what this public access is for. This is the purpose of this area is how I want to publish the data relative to this channel. Because it's configured as a digital input, it has state, it has latching, and it has a counter. So by simply selecting that I say, yes, I want to publish the counts, that's all I need to do. Now you see there as well, I have writable. But this is a digital input. What could possibly be writable? Well, maybe you want to reset that counter. Maybe you want to read and set it aside and reset it or whatever. Making it writable means one of those other software applications that are tied into the MQTT infrastructure can write that value and clear that latch. Okay, so let's take a step back. Indeed, I said it was a counter, and there is my counts. And as I continue to increment this thing, my counter is going up. Terrific. And I can change whether the counter is active here and so on. Let's dive into another one. I'm going to take a look here at this second channel, and that's an analog input. So let's click to take a look, and yeah, it's coming back in gallons. Well, that's kind of cool, right? Of course it is, because this is a 0 to 10 volt input. But I can't think of a single database or IIoT application that can make use of 0 to 10 volts. That's not meaningful data. What is meaningful is gallons, and that's what this is meant to represent. So I can come in here, I can put in my, my units, and I can scale from 0 to 10 volts is 0 to 5,000 gallons. Now I'm actually presenting some meaningful data relative to this analog input. Now I might need some calibration, some filtering, all of that is built in directly into the system. And then once again, I have my public access of how I want to take all the data and metadata associated with this voltage input and how I want to publish that data. So indeed, I want to publish the value. Maybe I want to publish its maximum and its minimum anytime it changes. And remember, this is MQTT and API access. But in the case of MQTT, I only publish on change. MQTT is a report by exception system. So only if I wanted to see the changes all the time, terrific. But maybe in the case of a 0 to 5,000 gallon tank, I only want to know if it goes outside the deadband of 5 gallons. So I enter that in here, and that can reduce the amount of information that I'm moving across a network. Same thing here, it's writable, so I can reset the mins and max should I find that necessary. Okay, pretty cool there. I'm going to show you one more channel. We're going to look at this panel light right here. This is an analog output. Okay, so, and it is voltage, 0 to 10 volts. So in this case here, looks like it 0 to 10 volts, and I have a way of writing to that value. So this panel light, well, what's that? Well, as I told you earlier, my PoE actually powers not only my RIO, but my entire system, my load panel, the switches, everything. And indeed, I'm taking some of that voltage and I'm powering up my LEDs on this backplane, my panel light. So let's go ahead and write a 0 to that by taking away the 1 there. And as soon as I tab out of this field, you'll see here, it turns it off, right? Pretty cool. Okay, let's go ahead and put it back to 10 volts. I think it's much prettier lit up. So there we go. And indeed, I'm writing to my analog output to confirm that its operation is good. All right. There's a lot more here, a lot more to go over, including, writing the outputs. I can click on the relays. I can toggle the relay on and off, pretty straightforward. But let's move on. What we've done is kind of a recap so far. We've created an account. We've confirmed our network settings. We have any security set up. We've created a backup now that I got my IO configured. Now we want to do something with the data, right? We need to move it to wherever it needs to go. Now, at this point, you could just access this device and all of it through Modbus and access everything I've configured. But what fun is that? This is IO for the IoT. Let's start moving this information directly into software. How do we do it? There's two ways. Number one is Node-RED. Let's talk about that for a minute. Now, Node-RED is, as I said earlier, it was developed by IBM, and it's built basically on the Node.js engine, which is a JavaScript engine, the same kind of engine that's actually in web browsers, and that executes essentially JavaScript code. But as I said earlier, this is a no programming approach. To develop the so-called JavaScript that actually executes on this Node.js engine, we use the Node-RED editor. Now, all I do is click on this button and watch what happens. I load up in my browser in a new tab the complete editing environment for Node-RED. There's no software to install. There's nothing to download. Everything comes right out of the RIO. It couldn't be any simpler. So here's the Node-RED environment. If you're not familiar with Node-RED, I encourage you to take a look. It's very powerful software, has a lot of extensibility and a large user community. It's free, it's open source, you can run it anywhere, and we've embedded it on RIO and on our Epic platform because of its power. So let's talk about it for a minute. Down on the side here, I've got all my nodes. Some of these nodes are default. In other words, they're installed automatically. Others you can install, and I'll get to that in a moment. Here's an example where I have a groov read node. And so this is a groov IO input, for example. I just drag these out on the canvas, and once they're there, I double click on them, and I can come over and configure where that IO channel might be. In this case, I am reading the temperature. It is on channel 3, so there's the channel 3 index, and I've given it the name read temperature. But also notice here the device. You see it says localhost? Well, that's because it's talking to itself, right? But I can enter in an IP address or a domain name, DNS name for another RIO or an Epic or virtually anything else that's running groov IO and pull that data in. So in one groov RIO, I may actually be talking to multiple groov RIOs and pulling all that data in. So it's pretty cool. There's a lot of flexibility there, but we're going to keep it simple here. We're just going to read the local temperature, and then we're going to do a very simple control. Okay, so I'm going to look at the temperature, and if the temperature is above 78, then I want to do something. So I double click there, and I'm in what's called the switch node. And so here it says, if it's greater than or equal to 78, I want to go out the little number 1 right there, okay? Otherwise, go out the number 2. And when I do so, I'll turn on the relay if it's over 78, greater than or equal to, or turn it off if it's below. Pretty straightforward, very simple logic. Now, this is a good time to take a pause and say, this is not a PLC. This is not ladder or designed to run real-time control programs. We're talking about a 1-second scan rate, and you're not trying to do critical control or anything. But it's very useful if you want to do some very, very simple tasks. So for example, here I'm looking at that relay, and it's number 9. Looks like the relay is already on. That means it's indeed warmer than 78 in here right now, which is a travesty. So watch this. I'll just come in here. I'm going to change this guy to 80, right? And I'm going to change the text on the thing to say 80. And done. And watch. When I deploy those changes, the relay went off. Now I'm waiting for it to get to 80. So once again, I'll go ahead and grab my temperature probe here. And geez, if it wasn't warm enough in here already. We'll get this guy back up to yep, there it goes. The relay is now on. So very, very simple control, very easy to do, and was certainly well suited for the task. read a 4 to 20 transmitter of a tank level. If the tank level exceeds a value, then you know, turn on a pump or open a drain, whatever. Real simple to do. Okay, let's talk about data logging. I mentioned through the USB exercise that I'm writing data to a local file. And indeed, here I am. So in this case, I'm writing every 15 minutes. I'm reading a temperature, and I'm going to go ahead and click it here. And indeed, look at this, writing to temperature log CSV. So that's exactly how it works. There's an inject node that on 15-minute intervals, I'll read the temperature, I'll name the records, and I'll write it to local disk. That's it. Pretty straightforward. Now, what if I didn't want to just write to local disk, but I also wanted to move this to, say, a cloud platform? Hey, no problem. I just come over here and grab a node for, let's say, Microsoft Azure. Oh, there is no Microsoft Azure in here. That's the beauty of Node-RED. Check this out. I'm going to come up here to the menu, and I'm going to select Manage Palette. And when I do so, and remember, my RIO has a path to the internet through my corporate network. So I'm going to come in here and look, I can search modules from a library of 2,500 Node-RED nodes. Watch this. I'm just going to type in Azure, and look at this. All of these Node-RED nodes are available for you to download and use. So maybe I want to send it all down, send it up through an IoT hub. I install that node, lay it on my canvas, and start wiring the data I want to go to the cloud right into that node, and I'm done. All from RIO. So I'm reading a temperature, sending it to a cloud service. Maybe I want to send it to a SQL database. Same thing, Manage Palette, click Install. Let's type in SQL and look at my options. I got Microsoft SQL in there. I've got, these are all Microsoft SQL because I pressed 2 S's. So if I just do SQL, there's MySQL, there's a number of different options there. So again, writing to an on-premise database, writing to the cloud, writing to a local drive. I can do all three, and I can do all three simultaneously, again, while it can still perform its job as a remote IO system. Pretty cool. But also what's nice is being able to not only store or archive data, but what about just alerting somebody? Here's an example where I'm looking at the top button. And if I press the top button, I'll quickly construct an email. It's very straightforward. It's just, you know, if the top button was pushed at, I'm just putting an email together. And then I'll send an email to Benson H. That's me at opto22.com. So I'm going to come over here, I'm going to press this top button, but watch where my cursor is. And when I press the top button, there it goes, it says sending. So indeed, it just constructed that email and sent it out through the configured email. Oh, there we go. My phone just buzzed, and indeed, I've got an email directly from my RIO. Pretty slick. Same thing here. Maybe you want to send an SMS. You want to tweet to the world that something happened, or you want to put something on your Slack channel. You name it, relative to messaging, Node-RED's got you covered. Okay, I could spend all day here. I'm very excited about Node-RED and have been. We also offer it on the Groov Epic system, just so much flexibility. Okay, look at this. I scrolled down to the bottom of my node palette over here, and I've got these dashboard nodes. So I got a button, I got a switch, a slider. Look at this, a gauge, a chart. What's all that for? Well, it allows me to build a quick and dirty, simple dashboard. And this is what it looks like. Here I'm reading a temperature, I'm rounding it up, and then I'm rounding down, and I'm putting it on a gauge and on a graph. Here I'm grabbing an image. Remember I was showing that image a bit ago? And I'm placing the image on the UI screen. Same thing here, reading a counter. Okay, what's this thing look like, right? Okay, let's take a look. I'll open back the tab where I had that image so I can show you where it's being used. I'm going to come up here and I'm going to select RIO Dashboard. So this is still coming from the RIO. As you can see here, it's just coming from a folder that's designed for all the UI, and look at that. Pretty darn cool. So there you go. I've got my little, my relay just went off and just went back on as I grabbed that temperature probe. There's where my graphics showed up. Look at my button counter there as I click that up some more. Move my cursor out of the way. I can turn on or turn off a relay. So let me bring this guy around. My number 9 is on, remember, because of my simple logic flow, and I'm over 80. Let's go ahead and turn on the relay, and you'll see the second one come on. And there it did. I'll go ahead and turn it off in case you missed it. Okay, so the UI is built in, ready to roll, but let me be clear. This is not Groove View. This is not Ignition Perspective or Vision. It's meant to be a really simple UI that's being served directly up from the RIO. It's not meant for 1,000 users or anything like that. But it is a very nice, simple UI, and it is built in. So there you go. Pretty slick, and that's all the time I have for Node-RED. So I'm going to go home and show you. I'm going to show you now the MQTT configuration because it's one of my favorite parts. And the other thing that makes it so elegant is its integration with the Ignition platform. And so indeed, my demo will show you how we can configure the MQTT service on this device, which as you can see is not currently configured. It's not publishing any data at this moment. And I do want to publish this into infrastructure or up to a broker. And then I want to have the Ignition gateway, an Ignition system that's also connected to that same broker and pulling all the data in. Let me see if I can give you a little bit better visual representation of what this looks like. I've created a little graphic here, and for a moment, I'm going to pull my screen off, or my image. And look at this. Here's my RIO Benson. It's connected to some IO. We got my tank level, my temperature, and so on. And once I configure MQTT, it will then take all the data that I've configured and publish it directly to the broker. In this case, I'm running a broker up on AWS. My friends over at Cirrus Link Solutions make the high availability industrial grade Chariot MQTT broker. They provided us with a license. I'm running it on AWS on a small little EC2 instance. So pretty sweet there. I'm going to configure to point to that broker at that address. But note that I have another RIO. There's one sitting over on my credenza I'll show you in a moment that is also publishing data up to the same MQTT server. And I've also got an Epic PLC back there that's tied to some Allen Bradley and Siemens PLCs. Maybe I should just give you a quick look. It's right here. This is the back credenza wall. Indeed, there's my Allen Bradley PLCs on their own network to my Epic. So that's publishing data. I've got my RIO demo right here, and it's communicating. Look at this. It's communicating through a small little Verizon router. So the only way that this guy is communicating any data is over a Verizon radio network, and it's publishing its data to the broker as well. So let me come back to my display, and yep, once I have all my systems publishing into infrastructure, I now will log in to the Ignition gateway on a Windows server here. And again, this is Ignition 8. Our good friends at Inductive Automation, who we work very closely with, has provided an Ignition 8 license for us, along with the Perspective module and the MQTT engine module. Now, the MQTT engine module is designed to also connect to the same broker and pull back all of these tags from all my publishing devices. So let's go ahead and take a look at that. I'll come back here to my live demo screen, but I want to get over to my Ignition. There we go. This is Ignition Designer running on that demo.groov.com server. And indeed, I can come over here to my tag browser and click on MQTT engine, which is going up to the broker and pulling back all these tags. Let's take a look. There's my edge nodes. Look at all these demo centers. They're all publishing data currently. Let's come down. Let's take a look at the Opto 22 group. I've got a couple epics, 3-4 different epics that are publishing data. Here's the Opto turbine. So indeed, I can come in there and there's my PLC data from my Allen Bradley PLC. So all of it's there. Oh, here we go. Here's RIO demo. And this is the one I told you is on the Verizon network. I click on Opto MMP, modules, channels, and that particular RIO is configured similarly to mine. So there indeed, I have a fuel level. I've got a temperature hanging off of that guy as well. He's not plugged in right now, but it's all there, all my data, all being published directly from that little RIO over a Verizon network. But I'm collapsing everything here because I want you to note something. There is no RIO Benson here, right? Well, that's because I haven't configured it yet, right? So I'm going to scroll back over to here, go back to Groove Manage on my RIO, and show you just how quickly and easily it is to configure this. So I'm going to click on Configuration, And here's basically it's fill in the blanks. And most of these blanks are what's called the topic namespace. And the topic namespace is defined by Sparkplug-B, an open source standard for defining topic payload, among a bunch of other things outside of the scope of this presentation. So I'm basically creating the folder structure of where I want the data to pop in. So let's go back over here to Ignition and take a look. I've got Opto 22, RIO demo, and so on. Let's do something similar. So I'm going to come in here and fill in the blanks. And we'll say the group ID is Opto 22. We're going to say the edge node ID is RIO Benson. I can put in an optional primary host ID. I'll leave that out for now. And then any unique ID for the device. I'm just going to call this one my RIO. Yeah, that's simple. Note here as well that I've got a historic queue where we can store values should we lose communications for a little bit, just like a little store and forward type backup. And that's it. I've now defined my topic namespace and my folder structure for where any application that ties to that broker can pull the data in and organize the data. Pretty cool. But yet I have not configured the broker yet. So let's do that now. Let's go here and you can see the broker URL. I told you this was up on Amazon and it's a Chariot broker. And I even showed you the URL back there. We're just going to do this over an unencrypted channel just for simplicity, so I don't have to put any server certificates or anything like, or client certificates in. But I do have to log into the broker. And this is one of the really cool things about this architecture is all the management of the usernames and so on are all done at the broker level. So I actually create usernames and passwords and everything at the broker, and that's my single point of managing this entire infrastructure. So I have a special login just for me to log in my data, and I'll go ahead and put in my password here. It's a rather long one because I don't want anybody to steal it from me. And there it is. I'm all done. I've configured the topic namespace and I said, that's where I want to send the data. I click save. Now watch what happens. I'm going to pull this guy back out over here so we can take a look at my RIO. I want to go ahead and start the service. And here's what's happening. As soon as I click yes, it is now taking a catalog of all of it's inventorying all the data tags that I chose to say publish, in other words, public access, and it's now sending all that data up to the broker. Now watch over here on my tag tree. I don't have RIO Benson yet, but in a moment, Engine here will actually go up and say, see, a birth certificate has been issued and I have access to that data. Boom, there's RIO Benson. Just by virtue of filling in the blanks, saying where the broker is, starting the service, and voila, I have this information directly in the Ignition platform. Now note that Canary Labs Historian has the same but similar functionality. Same and similar. It has a method of going in again and connecting to the broker and pulling all those tags in. So there's more and more software that is that not only works with MQTT, but also works with Sparkplug-B. But here's really the cool part. Let me scroll in, and just as I showed you before, RIO Benson wasn't here a moment ago. It is now, and so are all the tags, including the metadata for those tags. So remember on fuel level, I had its value and its minimum and its maximum. And because I said the min and max were writable, sure enough, I can come in here and hit 0, and my new minimum is the minimum that it's at right now. So I'll go ahead and crank that up a little bit so you can see the changes. So pretty slick, right? So now I've got real-time data coming from my RIO up into the Ignition platform by virtue of a few mouse clicks. So I've also got this blue ring LED. You saw it right there. I can change the state of that, but let's not do it from the tag browser. It's too much fun to do it otherwise. I have this screen up here from a perspective screen I built for another project I'm working on another demo. Let's go ahead and drop some of these values up there. So I'm going to take this guy. I'm going to pop him in and say he's a cylindrical tank. Okay, there we go. And let's change his capacity to 5,000. And boom, just like that, I've got a tank. Now let's take the blue ring LED and put its state up there too. Now note that the blue ring LED is an output, right? So that means I'm going to actually create a toggle switch on my screen here. And let's just move them up here by the tank. And I should be able to turn on and off that LED from this server on my ignition gateway. So I'm going to save my changes. There you go. And because I created a perspective screen, that means now on that server, I have an HTML5 page ready for me to view. So I'm going to scroll back over to my Firefox browser. And indeed, I've actually created a shortcut here. There it is. And I'll click on that. This is a public demo, so you can certainly click on it yourself or enter that into your browser and gain access to this system. And there you go. There's my tank level. Let's just move that guy a little bit and check that out. Pretty simple. Very, very straightforward. And this is why they call groov RIO Ignition IO. This notion of taking an IO data value and so quickly and easily publishing it in infrastructure and start building applications. That's how we make IIoT slick and easy to do. Okay, here's the output button. As you can see, my LED is on and I've got the toggle switch. But check this out. By clicking it, watch how fast this is. I'm going to click the button here and the light's already off. Did you see that? Did you see how high performance that is? Let me do it again. 3, 2, 1. Watch the video. Boom. That is remarkable. I mean, the thing about MQTT is there are so many numerous advantages to it. One, this gateway system didn't need to know the IP address of this. It didn't need to open up, a network port. I didn't have to get IT involved. I simply put this on the network, publish the data, and I have bidirectional communications to it. 2, the performance is astonishing. I mean, I am turning stuff on and off in way less than a second from anywhere in the world. And 3, it's highly secure. All the TLS and SSL encryption is supported. I have a way of managing users and passwords at the MQTT server. It really is the future of SCADA. This is the next generation of not only SCADA, but of IIoT, digital transformation, and Industry 4.0 projects. It just doesn't get any simpler than this. So with that, I hope you enjoyed my demonstration, the live demo of RIO, and learned a little bit along the way. And we certainly entertain and would love to hear from you about your IIoT and digital transformation projects. We have a top-notch crew of application engineers standing by at opto22.com, or give us a call at 800-321-OPTO, and we'd be happy to assist you with your projects and show you how quickly you can move IO signal data into software applications and start really making some progress on your IIoT projects, digital transformation, Industry 4.0, whatever you wish. My name is Benson Hoagland from Opto22, and I am thrilled to have been able to present to you. Thank you for your attention, and we look forward to working with you.